Hi. Okay, guys, welcome back. It's science o'clock, so we're starting a new topic. We're starting chemistry, C4 chemistry. We're going to start with group one of the periodic table. You've seen many of these things before, so a lot of this will be revision, but maybe a bit more information. But to start off, you're going to need a periodic table. You should have one in your planners. So turn to that, pause, and then answer these questions using your periodic table. You're not expected to have memorized that yet. So first thing, name 5 elements. Name 4 metal elements. 3 elements that have 3 shells of electrons. Elements that have 2 electrons in the outer shell. And last one, the element that has the electron arrangement 2881. Pause. Answer the questions. Go. You done? Excellent. Name 5 elements. I can't tell you which ones to do for 5 elements. You could have chosen titanium, chromium, iridium, osmium, arsenic, anything. Anything is fine for those 5 elements. Periodic table, it's kind of reversed here, but when it says metal, 4 metal elements, the easiest place to go is this section in the middle. These are the transition elements. This section here are the transition elements, transition metals. So if you pick any of those, chromium, manganese, iron, cobalt, nickel, copper, zinc, cadmium, silver, palladium, rhodium, any of those, they are metals. Easy. Elements that have 3 shells of electrons. Well, when you're looking at your periodic table, hopefully if you remember, going across are the periods. So period 1 just has hydrogen and helium in it. Period 1 has 1 shell. So period 1. Period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. That has 2 shells of electron. And period 3, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Any of those have 3 shells. If you wrote any of those, so possible: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, that would have been fine. Question number 3. Elements that have 2 electrons in the outer shell. If you remember, the number of the group tells you how many electrons they have in their outer shell. So group 1 has 1 electron in the outer shell. Group 2 has 2 electrons in the outer shell. So if you picked any element, beryllium, magnesium, calcium, strontium, anything from group 2, you would have had the correct answer. And let's do the last one. The last one sounds like it's going to be very tricky, but is actually not tricky at all. So here we have element that has the electron arrangement 2881. So first of all, we know, what do we know? We know that it has 4 shells. 4 shells, because there's 4 numbers, 2881. So we have to go down 1, 2, 3, 4. So we have to go down to the 4th row going across. But we also know the last one is number 1. If the last one is number 1, we just look down group 1. So go down 4, 1, 2, 3, 4, and the 4th element in group 1 is potassium. Okay. Did you get that? I'm sure you did. You're all very clever. Even you. Come on. There we go. Okay. Internet-based activity. Scientifically, what do these words mean? Hard, soft, brittle, strong. Pause. Maybe go to search engine, Google. Don't use Bing. Go to Google and find out what do the following words mean in terms of scientifically or material. Pause. Write those 4 down. Find out what they mean in a scientific sense. Go. Have you done that? Excellent. I knew you could do it. So, let me give you the answers. Hard is difficult to scratch or damage. So if something's hard, it's difficult to scratch or difficult to damage. Okay? Soft, on the other hand, is basically the opposite. It's easy to change its shape. So scratch or bend or squeeze or whatever should Be easy. Brittle doesn't bend or change shape, but snaps. And now, they don't always have to be weak. Something that's brittle, so a biscuit is a very good example of something brittle. You have a biscuit, like a nice rich tea biscuit, and you bend it. It won't bend, you try and bend it, and then it snaps. It's broken in half. So you can't bend the biscuit, you can snap the biscuit. But glass is also brittle. You can't really bend glass much, you can tiny amount, but it's quite strong. But when you do go so far, it will snap. So brittle doesn't have to be weak. It just means if you try and bend it, it won't change shape. It will be fine till it breaks. And the last one is strong, and this is kind of difficult to break. We'll say break or change shape. So it's not very easy to stretch, it's not very easy to change shape, and it can be very difficult to break. Important words that you need to know. Did you get that right? I'm sure you did, but if you didn't, maybe you want to change that and correct them. So pause, change. If you've got it all done already, okay, little activity. Which of these are the correct words for metals, as in the description? Can you write down the ones that are correct, ignoring the ones that are incorrect? Do you know what they all mean? So many things to do today. Okay, I'm going to pause whilst you write down. Yes? Okay, so let's check. Are metals dull? Dull in this case doesn't mean boring. It means not shiny, which isn't normally true. Most metals are often quite shiny. Are they silver? Apart from gold and bronze and copper. Do you know what? Most of them are, so I'm going to leave that. Tick. Malleable, so if you hit them, can they change their shape? Yes. Tick. Are they ductile? Ductile means you can stretch them, and actually a lot of metals you can. Tick. Are they brittle? Are they like a biscuit or glass? Are they strong? Yeah, they are generally quite strong. They're quite difficult to break. Are they hard? Some metals are hard, but some metals aren't. Like gold is very soft. In fact, you could bite gold, so that would not be hard at all. But then if you've got something like steel, that can be quite hard. So I'll put a question mark on that. Lustrous, is it shiny? Another shiny word. Yes. Do they have a high melting point? Well, apart from that one, mercury, yes, they all have a high melting point. Tick. Do they have a low melting point? Apart from mercury, so that's a no. Are they good conductors of electricity? Yes. Yes, they are. Are they reactive or unreactive? Some are unreactive and some are reactive. That was a rubbish question, and I apologise. Okay, another activity. I am working you to the bone today. So, first thing, write down this. Sodium, 11, Na, sodium, 22.99 for my periodic table, and your one will probably say 23. Write down, shall I draw that out? 23. There we go. What, using that and where it is in the periodic table, what can you tell me about sodium? Just no research, no internet, Googling anything, just from where it is in the periodic table and those numbers around it, what can you work out about sodium? Okay? Write it down. I'll wait. You might want to pause. Okay? Here's the answers I have prepared earlier. Did you get all of them? If you did, you have a prize. There's 10p. Okay. We know it's RAM. What does RAM stand for? Relative atomic mass, which means inside its nucleus there are 23 things. What are those things? Well, 11 of them are protons, because that number there says 11. 23 of them in the nucleus. So there's 11 protons, but in total, 23 things in the nucleus. The other things are neutrons, so 23 minus 11 is 12. we have 12 neutrons. We know it's an atom. It doesn't have any charge. So if it has 11 protons, it has to have 11 electrons. And I just said there, it has no overall charge. I'm just repeating myself. It is in period 3 of the periodic table. Na is in period 3, so it has 3 shells of electrons. So you can do that. It's also in group 1. Here it is. So it has 1 electron in its outer shell. We could actually go in even more detail. So we could say it has an electron arrangement of 2, 8, 1. I missed one out. Shame on me. It's solid because on your periodic table you can see from the colour of the letters of the symbol, different colours mean solid, liquid or gas. It's a solid. It's a metal because it's on this side of the table, and because it's in group 1 it forms ions of +1. We'll come back to that on another lesson, but hopefully you got all of those, and if you didn't, write them down. I'm not going to go through this. I'll upload this PowerPoint so you can look at this yourself, but it's a bit of a history of the alkali metals. I'm going to show you what they look like. Oh, my face is in the way. That says all alkali metals have 1 electron in their outer sheath. That should say shell. Okay, here's what they look like. If you ignore the nucleus, lithium, 2, 1. Group 1, row 2. So it has 2 shells, 2, and then 1. Sodium, it's in row 3, so it has 3 shells, 2, 8, 1. And potassium, that was in the starter, 2, 8, 8, 1. So all of them in group 1 have 1 electron in their outer shell. How many electrons do they have in their outer shell? Just 1. Okay? This means that they are found in group 1 of the periodic table. They have similar physical and chemical properties. There'll be a video in a moment which you can check. And they can readily lose 1 outer shell electron to form positive ions. So remember, what is it all atoms want? They want a full outer shell. Okay? How do you get a full outer shell? For example, let's look at lithium. Lithium has 1 in its outer shell. Now to get that shell full, it has to get 7 more electrons. Or it can lose 1 electron, so that shell disappears, and it just has that shell there that's full. So what's more likely? To lose 1 electron or to gain 7? Think about it. Obviously, losing 1 is much easier than gaining 7. So all of these elements, if they want to form an ion, they just get rid of that outside electron, boink, boink, disappear, and if you lose 1 electron, you end up becoming positively charged. I heard some of you say that, well done. So if you lose an electron, you lose 1 negative, so you become positive. Well done. Maybe you want to write something down. Maybe not. Oh, it's in a box. Nice. Okay, I'm not going to watch this video with you. Here's a link. I'll put the link on the VLE as well. Watch this. It shows you what they look like and what happens when you put them in water. I obviously don't have any of these in my house, so I can't do this for you. If you do have this in your house, please don't do this. How did you get them? Why did you get them? Stop it. It's dangerous. Just don't. Watch this video. Professionals have done it. Did you watch the video? It was really good, wasn't it? Well done. Okay, nice. Now we just need to look over just some things from before. All alkali metals, true or false? Write the numbers 1 to 7, and then just give it a T or an F. Pause whilst you do the answers. All alkali metals have the same number of electron shells. True or false? All alkali metals have the same number of electrons in the outer shell. True or false? All alkali metals can be found in their elemental form easily on Earth. Tricky. True or false? All alkali metals can be dangerous. True or false? All alkali metals form negative ions. True or false? And all alkali metals form positive ions. So let's go to number 1. All alkali metals have the same number of electron shells. Electron shells, row 1 has 1 shell, row 2 has 2 shells, row 3 has 3 shells, row 4 has 4 shells, and so on. If they're all in a different row, they can't have the same number of electron shells. That one is false. Did you write that? Good. All alkali metals have the same number of electrons in the outer shell. If you're in group 1, you have 1 electron in the outer shell. That is true. Well done. All alkali metals have the same number of electrons. Remember, atoms have the same number of electrons as they do protons. This one has 3, this one has 11, this one has 19, this one has 37. So no, that is not true. False. All alkali metals can be found in their elemental form easily on Earth. Well, you just watched the video and you saw how reactive they are. They just react with water. On Earth it rains a lot. So, no, you cannot find alkali metals in the ground or anything like that. They've all reacted. So you will never find them just lying around unless you steal them from a science lab. But that's not the same. All alkali metals can be dangerous. Yes, if something explodes if you put it in water, that is dangerous. All alkali metals form negative ions. Is it easier to lose 1 electron or gain 7? Lose 1, so they don't form negative ions, they form positive ions. I'm sure you got that correct. Well done. Okay, so we're just reviewing what you have seen in that video. Not very much. They are, hopefully you noticed in the video, with alkali metals, you can cut them with a knife. You can't normally cut metals with a knife. I would say go around your house and try cutting things with a knife, but that's probably really dangerous, so don't do that. But if you had an alkali metal, you can cut it with a knife. And as you go down the group, they become softer. When I say down the group, I mean at the top is lithium, and then sodium, and then potassium. So this one's quite hard. This one's getting softer, even softer, so soft, basically liquid. Bad. Stay away from this. So as you go down the group, you can cut them with a knife. They have a low density. How do we know that? If you noticed in the video, when they put them on water, they floated. Metals don't normally float just with it. If you like to throw a lump of iron on water, it doesn't float. Alkali metals do because they have a very low density. They have a low melting and boiling point. Well, they actually dissolved, but if you watch other videos on YouTube, you can see that the ones in the periodic table, as you go down, like liquid at room temperature. That's pretty crazy. So here's some examples of their densities. In the video, I think you saw they had lithium, sodium, potassium. They all floated on water. What happened to rubidium? Did it float? Did it not float? That's the one I think went bang. If water has a density of 1, anything with a lower density than water will float. So lithium, sodium, potassium all float on water. Rubidium is actually slightly more dense, so it wouldn't float on water, it would sink. Cesium also. So they go down. And if you get a piece of alkali metal and you leave it outside in the air and it doesn't get wet and it doesn't react, this is what it ends up looking like. It will look tarnished, almost dirty. But if you freshly cut it with a knife, or you burn off the outside. If you cut it freshly with a knife, it looks nice and shiny, lustrous. Here we go. Here, look how shiny. Oh, shiny. So they're stored in oil. Why do you think they're stored in oil? They're stored in oil so they don't get water on them and they don't get air on them. If you don't store them in oil, air means they tarnish quickly and water can get on them. So you store them in oil for safety, to keep the water and the air away. This is the end. Well done. Okay, so why don't you write down the answers? And maybe I'll give you the answers next lesson. Okay, so 6 questions. Name all the elements that have 1 electron in the outer shell. Number 2, write down the property of the alkali metals. Number 3, write down the alkali metals in order of reactivity. You know that from the video. What happens to the alkali metals when they are cut? What do they look like? How can you cut them? What happens to the hardness of group 1 metals as you move down the group? Do they get harder? Do they get softer? Remember, what does hardness mean? And what is the opposite of hard? Don't say not hard. If you do say not hard, you're an imbecile. Okay? Alright, sausages. Thanks for listening. Love you. Bye.